So we want to find the limit as x approaches 0 of x to the 2 over x. So first, let y be x to the 2 over x, and then take the natural log, or ln of both sides. So we get ln of y equal to ln of x to the 2 over x. Since we have ln of x to the 2 over x, we can move this exponent 2 over x out in front. And so we end up with ln of y equal to 2 over x times ln of x. And then take the limit of both sides as x approaches 0. This is limit of the product. So it's just going to be limit of 2 over x times the limit of ln over x as x approaches 0. So as x approaches 0, and then 2 over x will approach infinity. We can look in the graph here and see the graph for 2 over x. So this is the graph for 2 over x. This is the x-axis. So if we start on the right side here and then move closer and closer and closer to 0, we see that the graph is going to go infinitely up. So as x approaches 0 from the right, the y or the f of x will go up infinitely, or will go to infinity. So as x approaches 0, 2 over x will approach infinity. And then ln of x, we could also look at the graph of ln of x. So again, I'm starting on the right side and approach 0 from the right. Approaching 0 from the right, we see that the graph goes infinitely down. So as x approaches 0 from the right, y or ln of x will go infinitely down, or negative infinity. So one more time, if we approach 0 from the right, the y or the ln of x will approach negative infinity. So this is positive infinity. This will go to negative infinity. And then positive infinity times negative infinity is just negative infinity. And so now we end up with the limit as x approaches 0 from the right of ln of y is equal to negative infinity. And what we're looking for is the limit of y, not the limit of ln of y. So how do we go from limit of ln of y to limit of y? Remember, we have a theorem on the limit of a composite function, and it says that if you have limit as x approaches a of f of g of x, then this is the same thing as f of the limit of g of x. And so think of ln as f, think of y as g of x. So we can rewrite this right here. Rewrite the limit of ln of y as ln of the limit of y. But if the limit of this quantity is equal to negative infinity, then this quantity has to approach 0. And when we look at the graph earlier, we can look at the graph again. So ln of this quantity is equal to negative infinity. Then this quantity has to go to 0. So the only way to get f of x to negative infinity, and then the x has to go to 0, has to approach 0. And therefore the limit of y as x approaches 0 is equal to 0. But y is our original expression. Y was x to the 2 over x. And therefore the limit of x to the 2 over x as x approaches 0 from the right is 0.